Let's go to LeetCode 912, sort an array. For this question, it gives us an integer array, and let's solve the sorting array problem without using any built-in functions, using O n log n time complexity. We know some other sorting, like bubble sorting or this kind of sorting, is O n square. And for n log n time complexity sorting, there are merge sort and quicker sort. And they may have some other sort like heap sort. But for the heap sort, the way to use heap sort to solve problem, it's rare. It's not that many. So we'll talk about quicker sort and merge sort. So for quick sort is that we use a left pointer and right pointer, and we randomly pick a pivot, right? Pivot as a number. So as long as the left pointer, this kind of value is less than this pivot, then we'll move the left pointer until it hit a point, a value which is greater equal to pivot. On the right, do the same thing. As long as this kind of number is greater than pivot, then move the right pointer to the left until it hits that this number is smaller equal to this pivot. Then we do the swap until the left and right pointer meet. Right, so that's then this is that after we left and right pointer meets, right? So all of the numbers smaller than smaller equal to this pivot has been put in this part, and greater equal to this pivot will be good to this part, right? Then we recursively do the left part and the right part. So let's begin to write code for this, right? So let's write some corner case if nums equals to none, or nums total length equals to 0, right? We return none, right? Then we'll have quick sort nums. We start from 0, from to end. This is end, right? So that was nums dot length -1, and the return nums. Okay. So private void quick sort. Okay, so we have this one nums in the start and end, right? So let's say for this start is greater or equal to end, which should return, right? Exit return. So we have int left equals to start right equals end, right? So we are going to have a pivot. We can write nums start plus end minus start divided by 2. Then we write wow, this left smaller equal to right, and what we do is that let's say wow, left smaller equal to right, and nums left, as long as this one is smaller than pivot. So this smaller because if hit a number equals pivot, we also want to swap, right? So in this case, we'll have left, keep it moving, right? And also we'll have while right, left small equal to right, and nums right greater than pivot, right? Then we'll have right minus minus. And I will say if left smaller equal to right, right, then we'll do swap into temp equals nums left, nums left equals nums right. And nums right equals temp, right? And then we'll have left move and right move, right? And after doing jumping out of this while loop, right? So the left will be here, start here, right? And right will be on the left or right. Right will on the left of the left, right? And the end. So this is left, this is right. So we'll divide conquer to do this part and this part, right? So what we do is that we need to quick select, quick sort, nums start right. And also we'll have quick sort nums left and right. Here, we put pivot as the middle of this, right? So for this one, it's not optimal. Actually, for pivot, the optimal way is that we use a random index in the start and the end, right? Because the Python, if you write this, it will tell you it has some kind of test cases it will not pass through. So what we do is that we can create a random equals new random. So instead of doing this part, we'll have write something like start plus random next it end minus start plus one, right? Something like this. This will be more efficient. Line 9 into start. PRIVAT. Line 7. Okay, so this is a quick thought. I change this to Python code. So the Python code is doing similar, right? So we'll say if nums is num or length nums equals to 0, right? That's what we can. And we are going to have pick sort nums 0 length nums minus 1, right? And after doing that, we just return nums. Right? So we define the df quick sort nums. It is a list int. And we have a start int and int, right? So we'll say if start of greater equal to end, we just return, right? And I will say pivot, right? Pivot we'll have nums. We'll have random in passing right like this random dot rand it left right. Okay. So I have I j equals start. Okay, so we'll have left right equals start need end, right? So I say while left smaller equal to right. I say while left smaller equal to right. And nums left smaller than pivot, right? Then we'll have left keep moving. And I will say while left smaller equal to right, and the nums right greater than pivot, we'll have right minus equal to 1, right? And I will say if we stopped, right, and you will say if left smaller equal to right, then we need to swap. So nums left, nums right equals nums right, nums left, right. So I have left plus equal to 1, right minus equal to 1, right. And after this, we need to divide conquer on the left part. Quick sort nums start right. Quick sort nums left and right. Left and right. There should be start end. Okay, so this is a quicker sort, right? And there is another one which is called a merge sort, and we also need to go over those kind of merge sort, right? For merge sort, what we do is that we need to create a temporary, right? And the thing we need to make sure that is before we do that, we create this array once instead of for every merge sort we create a small temporary. Create this one for one time will be more efficient. And then we divide this to two parts, right? And we use a temporary for we divide we keep dividing right? So until we have the smallest one, right? And we have left right, and we then do the merge, right? And we merge is that for example this one merge to temp, right? Temp. Then after we merge to temp, we call back to this nums array, right? So it is also some kind of divide conquer way, right? So it is separated the array to half and half, and then merge this, and after the merge, right? So it may merge this part as well, right? Then this part and this part merge to this, and then this part and this part merge, right? So that is the merge sort. So let's begin to write code for this actually. So we also need a fucking nums equals to num or nums dot length equals to 0, which is a return num, right? And we need to write a merge sort function, right? So nums dot length, and we need as we talk about we create a temp array here, right? And new int and we'll have merge sort nums in the temp and our start and our end, right? Return return nums. So this is so we'll have private int void, okay, merge slot. Okay. So we have nums in the temp, right? And in the start in the end, right? So what we do is that for this start is greater equal to end, we just return, right? And what we do is that we need to have a middle, and mid equals start plus end minus start divided by 2, right? So we'll divide conquer to sort the left part, nums and in the start in the mid, right? And we should merge sort nums temp mid plus 1 in end, right? And then we should merge nums temp and start and the mid and end, right? So now let's write our merge function. Merge have nums and we have a temp, we have a start, we have a mid, we have a end, right? So what we do is that we have a left equals start, right equals to mid plus 1, right? And let's have an I index. I equals start, right? So what do we do is that while this is left smaller equal to mid and right smaller equal to end, right? So I say if nums nums left small equal to nums right, then we put the smaller one to the temporary, right? So we'll have temp I plus plus equals nums left plus plus, and what's the else we'll move the right pointer, right? Else we'll have temp I plus plus equals nums right plus plus, right? In the after then we should also check the left pointer, right pointer, right? So if y left smaller equal to mid, we still need to have temp I plus plus equals nums left plus plus, right? And let's say y right smaller equal to, and we still need to have temp I plus plus equals nums right, right, plus plus. And in the end, we should copy back this kind of temp because we already merged to a temp array. Then we need to sort from this start to end to this nums, right? So we should copy back. So for int k equals start, k small equal to end, k plus plus, we have nums k equals temp k, right? So this is a merge sort. If start, if not it, line 9 nums. And Python code, right? Python code. So let's say if nums is none or length nums equals to 0, right? We're going to return. Otherwise, we have a equals length nums, and we have temp right here because 0 multiplied by n, right? So we'll have merge sort nums temp, and we'll have 0 and -1, right? So we'll just return nums. And we should define merge sort function, right? Define merge sort, right? So we'll have nums that is a list int, and we'll have temp, right? Temp which is also a list int, right? We should have a start. Start is an int, and the end is an int, right? So what we do is that if start greater equal to n, right? So we do nothing, return. And we have a mid, mid equals this start plus n, doing like this, right? Mid. Then we'll have merge, divide conquer, merge sort nums temp start mid, and merge sort nums temp mid +1 and n, right? Then we'll have a merge function, right? Merge nums temp start mid and so we are going to define a merge function here. So we should have a df merge. So we'll have nums, right? It's a list and temp, right? Temp, this is also a list. And we'll have a start. This is an int, and mid. This is an int, and which is an int, right? So let's say we are going to have an left, right, and I close start, mid +1, right? And this I is actually start. Let's say while and left small, not princess left smaller equal to mid, and the right smaller equal to n, right? So let's say if nums left smaller equal to nums right, right? So that means we are going to, the left one is smaller, right? So I have temp I equals nums left, and we'll have a left plus equal to 1, right? And I plus equal to 1. And we'll say else, else we'll have temp R equals nums right. I have right plus equal to 1, and I plus equal to 1, right? And then the while loop, right? So the left may not finish, also the right may not finish. If left is still, while left is small equal to mid, right? So what we do is that we're going to have temp equals nums left, and we're going to have left plus equal to 1, I plus equal to 1, and we'll also have our while loop right smaller equal to n, right? So we'll have temp I equals nums right, and we'll have right plus equal to 1, and I plus equal to 1, right? And now we need to copy this kind of temp to our original array, right? So what we do is that for example k in range start and n +1, right? So we'll have nums k equals temp k. So this is a merge part. I list line 26, temper, while left smaller 26. This is right. Right plus equal to right plus equal to not left. Okay, so this is a merge sort, right? So both sort algorithm have n log n time complexity. Actually, you'll say merge sort is strictly n log n time complexity, and quick sort is averagely n log n time complexity. The reason is that why we call it averagely, because sometimes in some kind of corner cases, if the data is select, for example, not very good, right? So in that kind of cases, the quick select may be worsened to be n square time complexity. And so in this case, you see, we put the pivot as a random, right? Use a random, it will pass. If we just sometimes use a start plus and divide by 2, right? And this kind of case in Python code, it will have TLE. That is because we'll say quick select is not a stable n log n time complexity, but since the space complexity for merge sort, it has ON space because we is a temp array, but for quick sort, quick sort, it is a constant, right? No extra space.